Good morning. My name is K.Purushotham, working as assistant professor in the Department of Electronics and Communication from MLR Institute of Technology. So, previous class I discussed about what are the modulators we are using for the generation of the amplitude modulation. So, now I am going to discuss about what are the demodulators we are using for the detection of the amplitude modulated wave. So, here the overview of this lesson is nothing but today I am going to cover what are the different types of detectors we are using. So, one is square law detector and another one is envelope detector. So, same way what we have discussed in the previous class. So, there square law modulator we are using and switching modulator we are using. Here square law detector and envelope detector we are using. So, what is the purpose of the detector? So, we are transmitting the original information signal along with the carrier. The carrier signal we are using for the modulation. The characteristics of the carrier is changing according to the original information signal, and that signal we are transmitting to the transmitter side. So, at the transmitter side, it is containing the carrier signal and original information signal. And that signal is propagating through the free space in the form of electromagnetic waves. And at the receiver, we are receiving through the antenna. Here one antenna we are connecting. Through that antenna, the modulated signal what you are transmitted from the transmitter side, that information we are receiving at the receiver. So, received signal S of t we are representing. That is modulated signal what we have transmitted from the transmitter side. Same signal we are receiving at the receiver. So, in between the channel is there. Through the channel, there is a possibility of noise is entering into the communication system. So, at the receiver, we are operating such a way that we are trying to reduce the noise in the signal and we are concentrating only the information signal. So, only we have to extract the information signal and we have to remove the noise signal and we have to remove the carrier signal. But removal of the noise is very complicated. We are trying to reduce the noise by using the different digital signal processing algorithms and by using the low pass filters. Different types of filters we are using. We are trying to reduce the noise in the received signal and we are trying to extract the original information what we have transmitted from the transmitter section. Okay, so for that we are designing the demodulators. So first demodulator is the square law demodulator. The square law demodulator is used to demodulate low level AM wave. The following is the block diagram for the square law demodulator. So the square law demodulator block diagram is containing first AM wave. AM wave is nothing but modulated wave S of t, which can be represented as AC cross 1 plus Ka m of t cos 2 pi fct. Okay, so that modulated wave we are applying to the input of the square law device. So the demodulator contains a square law device and a low pass filter. The AM wave V1 of t is applied as the input to this demodulator. So what is the V1 of t? V1 of t is the modulated signal. So that can be represented as a AC cross 1 plus Ka m of t cos 2 pi fct. Okay, V1 of t we are applying to the input of the square law modulator. We know the mathematical relationship between the input and output of the square law device. The square law device, here AM wave we are applying as a V1 of t and the square law output what we are getting is V2 of t. The V2 of t is nothing but K1 V1 of t plus K2 V1 square of t. Due to the square law characteristics, V2 of t can be represented K1 V1 of t plus K2 V1 square of t. Okay, so the V1 of t value if you are substituting in the expression or in the equation number 1, the V1 of t is AC cross 1 plus Ka m of t cos 2 pi fct. That expression V1 of t in place of V1 of t we are substituting here. So after substituting, so what are the expressions we are getting here? K1, K2 are the constants. Okay, so the expression what we are getting K1 A1 cross 1 plus KAM of t cos 2 pi FCT plus K2 AC cross 1 plus KAM of t cos 2 pi FCT whole square. Okay, let us expand this one. Okay, after expanding that one, what is the expression we are getting? K2 AC square. This AC is nothing but AC square. 1 plus Ka square M square of t plus here 1 whole square is nothing but 1. This is Ka M of t whole square is nothing but Ka square M square of t. 2AB 2 Ka M of t 1 plus cos 4 pi FCT by 2. Okay. So after expanding that expression, we are getting this expression. So now V2 of t, the finalized expression what I am getting, the number of terms are K1 AC cos 2 pi FCT plus K1 AC Ka M of t cos 2 pi FCT plus K2 AC square by 2 plus K2 AC square by 2 cos 2 4 pi FCT plus K2 AC square Ka square M square of t by 2 plus K2 AC square Ka square M square of t by 2 cos 4 pi FCT plus K2 AC square Ka M of t plus K2 AC square Ka M of t cos 4 pi FCT. Okay, there are n number of terms we are getting here. So among the n number of terms, we are only allowing the desired amount of the signal. So what is the desired amount of the signal? K2 AC square Ka M of t, where K2 AC square Ka M of t is the wanted signal. K2 AC square Ka M of t is the wanted signal. This is the wanted signal or desired signal. Desired signal. So this term is the DC term. DC term. So this is containing only carrier. Is containing only carrier. Carriers does not have any information. Only for taking the information for the longer distance, we are taking the carrier. Okay, and here carrier is containing and M of t. Both signals are there. Okay, only we want M of t. It is containing the carrier plus M of t. Here it is containing only carrier signal. Here it is containing non-linear term M square of t, message square. Okay, this is the non-linear, we are not at all concentrating. Here it is containing the carrier signal plus non-linear terms of the message signal. Okay, here it is containing the message signal multiplied with the carrier signal. Okay, at the receiver what we are expecting? So original information signal we have to extract from the received signal. Only original information term where it is containing K2 AC square Ka M of t. AC square, AC is the amplitude of the signal. Amplitude square is not a problem. Okay, only the M of t is there. That M of t is the message signal. So it is only the wanted component. This wanted component is allowed through the low pass filter. This wanted component is allowed through the low pass filter. This wanted component is allowed through the low pass filter. And we are obtaining the original information signal. The above expression, the term K2 AC square Ka M of t is the scaled version of the message signal. K2 AC square is the scaling factor which is multiplied with the M of t. Okay, these two terms are the scaling factors. And it can pass above signal through the low pass filter. Okay, the DC component K2 AC square can be eliminated by using the coupling capacitor. The coupling capacitor, what it is doing? It is only allowing the AC signal. It is blocking the DC component. The capacitor, what is the property? It will not allow the DC. It will allow only the AC component. It blocks the DC and allows the AC. Okay, the DC component can be blocked, and remaining what are the component it is allowing? The low pass filter is allowing only the message signal with the scaling factor. Scaling factor is nothing but K2 AC square is the scaling factor which is multiplied with something, that is the integer value. So finally the demodulation, the square law demodulator, what is the output we are obtaining? message signal what we transmitted from the transmitter section, same message signal we are obtaining at the receiver side. Okay, that we are calling it as a demodulated signal of the square law modulated output. Okay, demodulated signal. So what we are transmitted, the square law modulated output we are transmitted, and that we are applying as the input to the demodulator, and finally what we are obtaining, message signal only we are obtaining. Next demodulator is envelope detector. So the envelope detector is used to detect the high level AM wave. High level AM wave. Following is the block diagram of the envelope detector. So here envelope detector, we are applying the S of T connected to the source resistor RS, that is applied to the diode, and one more section. This section what we are calling it is nothing but low pass filter. Okay, capacitor which is connected in parallel with RL is acting as a low pass filter. Is acting as a low pass filter. So here the operation, the envelope detector contains the diode and the low pass filter. Here diode is main detecting element. The diode is main detecting element. The envelope detector is also called as a diode detector. The envelope detector is also called as a diode detector. The low pass filter contain parallel combination of the RL in series in parallel with the CL. RL and CL. The AM wave S of T is applied as the input to the detector. So what is the S of T? S of T is AC cross 1 plus Ka M of T cos 2 pi FCT. Cos 2 pi FCT. So if the received signal is the positive half cycle. So what is the general S of T waveform? S of T waveform is containing like this. Let me take modulation index mu is less than 1. Modulation index is mu less than 1. Okay, this is the S of T, modulated signal. Okay, so S of T, modulated signal. So here S of T AC cross 1 plus KM of T cos 2 pi. In the positive half cycle, of the AM wave, diode conducts and capacitor starts charging. In the positive half cycle of the AM wave, the capacitor starts charging through the path RS and C. Charging, capacitor is charging here. Capacitor is charging with a time constant RSC. Okay, capacitor is charging with the time constant RSC. The charging time constant should be very, very low. Tau is equal to charging time constant. Constant should be very, very low. Very low. So if you are maintaining very low time constant, that is RS value is very less. So the capacitor, what it is doing, immediately is charging to the input signal. Okay, what is the input signal? S of T, positive half cycle. In the negative half cycle, so here S of T waveform, if I am taking S of T waveform, if I am taking for 100% modulation, here positive half cycle. This is the negative half cycle. In the negative half cycle, diode is reverse biased. Once the diode is reverse biased, what is happening? The capacitor initially which is charged to the positive half cycle, now it is discharging through the path of RLC. Capacitor is discharging capacitor C discharging with RLC. So what is the RL value we are maintaining? Very high value we are maintaining. So the discharging time constant is very high. So capacitor is slowly discharging. Okay, capacitor is slowly discharging means in the positive half cycle, just capacitor is up to here charging and it is slowly discharging. Slowly discharging means immediately, and next cycle is coming. Next cycle is coming. So immediately capacitor again is start charging. Okay. So here in this period capacitor is charging and in this period slowly discharging. Slowly discharging and next cycle is immediately coming. Next cycle immediately coming means again capacitor is starts charging. Okay. And in the negative half cycle again capacitor is discharging. Capacitor is discharging and next cycle is coming means immediately it is charging. Okay, so the output waveform what we are expecting, so the output waveform is containing the sinusoidal signal. The output waveform is containing the sinusoidal signal. The envelope detector is following the sinusoidal waveform. So that is the original message signal is also containing in the sinusoidal form. So see here, the diode conducts the capacitor charges to the peak value of the AM wave. Okay, when the value of AM wave is less than this value, that is less than the peak value, the diode will be reverse biased. That is in the negative half cycle, in this duration, the diode is immediately reverse biased. So once the diode is reverse biased, the capacitor starts discharging through the path RL. Okay, till the next positive half cycle of the AM wave. Okay, when the value of AM wave is greater than the capacitor voltage, when the value of the AM wave is greater than the value of the capacitor voltage, diode starts conducting. Diode starts conducting and the process will be repeated. So what we are obtaining here? So here, see here, let me take the waveform. So this is the amplitude. So here see here, S of t. So initially the capacitor is fastly charging to the S of t value. Okay. So it is reaching to the peak value of the capacitor. Input voltage, peak value of the input voltage it is reaching, and the capacitor voltage also same to the peak value of the input voltage. Next here the voltage is decreasing. In this decreasing, that is in the negative half cycle, what is happening? Capacitor starts discharging through the RL. So RL value is very high. So RL value is high means discharging time constant is also very high. Slowly discharging, and before it is discharging, next positive half cycle is coming. Next positive half cycle means the peak value of the input signal is greater than the discharging value of the capacitor. Here peak value of the input signal it is reaching, discharging value of the capacitor voltage is here. So immediately what is happening? Again capacitor starts charging. Capacitor starts charging up to a peak value of the input signal. Again the peak value of the input signal is reducing means the capacitor starts discharging. Discharging up to here it is discharging. Once the next to positive half cycle it is coming means immediately starts charging. Okay, so the output waveform what we are obtaining is nothing but the envelope of the signal. Original information where it is concentrated on the envelope of the signal, only original information is concentrated. The output waveform what we are able to obtain, this is the output waveform we are obtaining across the amplitude modulated or demodulated output. Okay, this is the output waveform, sinusoidal signal what we are expecting, what we are transmitted from the transmitter side. Okay, the sinusoidal signal envelope is following the sinusoidal nature of the signal. So where original information is concentrated. Okay, so the only the drawback is how to select the charging time constant and how to select the discharging time constant. Okay, there is a one relationship is there. Based on that, we are designing the demodulator by using the envelope detector. Okay, so that is the envelope detector which is used as the demodulation of the amplitude modulated wave. Most of the applications we are concentrating on the envelope detectors. Okay, so this is about the AM modulator we have discussed and AM demodulation section. First AM demodulator of the today's session is nothing but square law detector, which is used for the detection of the amplitude modulated wave, and the second demodulator is nothing but envelope detector. Okay, which is used for the most applications for the detection of the original information signal which is concentrated in the transmitted information. Thank you for your